talking to you about the biological control of the woolly aphid using entomopathogenic nematodes. Woolly aphid is an important pest of apples occurring throughout the apple growing regions of the world, including South Africa. It feeds on the shoots, the wounds, and roots, resulting in gall formation, which then affects the uptake of plants and nutrients and water by the plants. In South Africa, the control of woolly aphid currently relies on a combination of resistant rootstocks, chemical and biological control. But with the inability of the parasitoid Elise-Marie to control this pest early in the season, we thought that it is important to consider entomopathogenic nematodes as an alternative biological control agent for this insect. These nematodes have generated a lot of interest as innovative biological control agents of insects. Their life cycle has been explained already, but I would like to emphasize on the importance of their symbiotic bacteria. Therefore, the aim of this study was to look at the potential of these nematodes to control woolly aphid. We used the 24-well bioassay protocol to screen a total of 7 isolates. Basically, what we did was we exposed the woolly aphid individually in the 24-well bioassay plate. After this, then the plates were incubated, and we dissected the insects to confirm mortality after 2 days of infection. We also did a direct screening using bacteria and insect extract. And in this, we simply collected woolly aphid from the field, and we took about 1,000 aphids, put them in an append tube, and then we crushed them just to get the insect extract. And for comparison, we also used the extract of codling moth and wax moth. From the screening, Serenema which is 157C, caused the highest mortality. But what struck our interest was that upon dissecting the insects, we saw that the inside of the insects was not liquidified, and the insects did not even change color. And some of the aphids that were still alive had nematodes inside. So we knew that something was up, which is what prompted us to do the direct screening of the bacteria. And the results of the direct screening of the bacteria then confirmed our worst nightmare. Indeed, the hemolymph of the woolly aphid has got something that inhibits the bacteria from growing. This then explains the poor results that we got. And we compared this with the wax moth. You can see the bacteria grows nicely, and in the codling moth. But when we used the woolly aphid extract, the bacteria just didn't grow. This then was a major setback for us, but giving up was not an option. We therefore had to think very fast, and after consulting with some wise people like Dr. Pringle, it was clear that entomopathogenic fungi was then the way to go. And we started by looking at the 2 commercial isolates because they were available easily. And those were Bavaria bassiana and Metarhizium anisople. And we inoculated them both on shoots and on roots. So we basically collected woolly aphid from the field, and then we established our colonies in the lab. And I'm happy to report that both EPF isolates have caused mortality that's more than 50%, both in the leaves and on the roots. I'm sad to say that even though these nematodes do invade and kill woolly aphid, the fact that their life cycle is not completed within the insect limits their effectiveness as the biological control agent of this pest. Entomopathogenic fungi, though, has showed a great potential, and therefore now more research is being done now to compare the commercial isolates with the indigenous isolates. Thank you.